Classification of bearing based on directions of force. Radial bearing. A radial bearing supports load which is perpendicular to the axis of the shaft. Thrust bearing. It supports the load which acts along the axis of the shaft based on type of friction. Sliding contact bearing. Example, plain bearing, journal bearing, sleeve bearing. In this, the surface of the shaft slides over the surface of the bush. To reduce friction, these two surfaces are separated by a film of lubricating oil. Bush is made of white metal or bronze. Rolling contact bearing, anti-friction bearing. In this, sliding friction is replaced by rolling friction. Example, bearing used in machine tools, spindle, automobile axles, gearboxes, small size electric motors. For starting condition and at moderate speed, the frictional losses in rolling contact bearing are lower than that of an equivalent hydrodynamic journal bearing. Types of rolling contact bearings. Deep groove ball bearings. The radius of the ball is slightly less than the radius of curvature of the groove in the recess. It gives a point contact. Due to point contact, there will be less friction loss resulting in less temperature rise and less noise, so maximum permissible speed is high. Advantage. Due to large ball size, the load carrying capacity will be high. It can take load in axial as well as radial direction. Disadvantage, self alignment is not possible for rigidity due to point contact. Cylindrical roller bearing. It is used when maximum load carrying capacity is required in a given space. Advantage, it gives a line contact so it is more rigid. Thus, radial load carrying capacity is high. Frictional loss is less in high speed application. Disadvantage, in general, it cannot take thrust load. Self alignment is not possible. Angular contact bearing. The grooves in the inner and outer races are so shaped that the line of reaction at the contact between balls and races makes an angle with the axis of the bearing. Advantage, it can take both radial and axial loads. Load carrying capacity is more than deep groove ball bearing. Disadvantage, it must be mounted without axial plate. Two bearings are required to take the thrust in both directions. It is assembled with a specific magnitude of preload. Self-aligning bearing. The external surface of the bearing bush is made spherical. The center of the spherical surface is at the center of the bearing. Therefore, the bush is free to roll in its seat and align itself with journal. Arrangement is made to provide lubricant between the spherical surface of the bush and its seat in order to reduce frictions used in agricultural machinery and railway axle boxes. This has less load carrying capacity compared with spherical roller bearing. Taper roller bearing. They are arranged in such a way that the axis of individual rolling elements intersect in a common apex point on the axis of the bearing. This is an essential requirement of pure rolling motion between conical surface. When subjected to pure radial load, it induces a thrust component and vice versa. Advantage, it can take heavy radial and thrust load. It is more rigid. It can be easily disassembled and assembled. Disadvantage, two bearings are required to balance axial force. Preload is required. It cannot tolerate misalignment. Application, car, truck, differentials, proper shafts, railroad, axles, box, large size bearing, rolling mills. Thrust ball bearing consists of a row of balls running between two rings, the shaft ring and the housing ring. Balls and inner outer races are made of high carbon chromium steel and rollers are made of case hardened steel. Use in gearboxes. Advantage, large number of balls lead to high thrust load carrying capacity. Disadvantage, it carries thrust in only one direction. It cannot carry radial load. It is not self aligning. Performance is good only for low and medium speeds. It requires application of continuous pressure applied by a spring to hold the rings together. Use worm gearboxes, core hooks. Selection of bearing. Application requirements, type of bearing, low or medium radial load ball bearing, heavy load roller bearing, misalignment self aligning bearing, spherical roller bearing. medium thrust thrust ball bearing, heavy thrust cylindrical thrust bearing, load in either direction double acting thrust bearing, radial and thrust load both, deep groove bearing, angular contact bearing, spherical roller bearing, high speed deep groove ball bearing, angular contact bearing, rigidity double row cylindrical roller bearing, taper roller bearing, less noise deep groove ball bearing. Static load carrying capacity, static load defined as the load acting on the bearing when the shaft is stationary. Static load carrying capacity defined as the static load which corresponds to a total permanent deformation of ball and races at the most heavily stressed point of contact equal to 0.0001 of the ball diameter. Dynamic load carrying capacity defined as the radial load in radial bearing, thrust load in thrust bearing that can be carried for a minimum life of 1 million revolutions. It is based on the assumptions that the inner race is rotating and the outer race is stationary. Equivalent or actual bearing load. The equivalent dynamic load is defined as the constant radial load in radial bearings, thrust load in the thrust bearing, which if applied to the bearing would give the same life as that which the bearing will attain in actual condition. F equivalent x VFR plus YFA, where F equivalent dynamic load, FR radial load, FA axial load, X radial factor, Y thrust factor, V rest rotation factor is equal to 1 when inner rest rotates, 1.2 when outer rest rotates. Point to remember, in case of pure radial load, F equivalent will be equal to radial load, and in case of pure axial load, F equivalent will be equal to axial load. Bearing life under variable load. L is equal to C by F to the Q million revolution. Here C dynamic load capacity, F equivalent dynamic load, C by F loadings rate. The value of Q is equal to 3 for ball bearing and Q is equal to 10 by 3 for roller bearing. Designation of ball bearing PQRS. Here P type of bearing, Q indicates series extra light to light, medium, heavy. RS when multiplied by 5 it gives the shaft diameter in mm. Bearing failure, abrasive wear, cause dust, rust, spatter, remedy, oil seal, increase surface hardness, use of high viscosity oil, corrosive wear, cause water, moisture, corrosive elements in lubricant, remedies, complete enclosure, proper additive, put pitting wear. Pitting is the main cause of the failure of anti-friction bearing. It occurs when the load on the bearing part exceeds the surface endurance strength of the material. It depends upon the number of hot contact stresses and number of stress cycles. So surface endurance increases by increasing surface hardness. Scoring, excessive surface pressure, high surface speed, and inadequate supply of lubricant results in breakdown of the lubricant films. It is also called stick slips phenomenon. Needle bearing. It has cylindrical roller having very small diameter and relatively long length. It is also called a quill bearing, L by D greater than 4. This can be used with or without inner and outer rest. This is suitable where limited radial space is available. Used in oscillator motion, piston pin bearing, rocker arms, universal joints. Advantage, used to replace sleeve bearing because the outer diameter is less. It has a large load carrying capacity compared to its size, particularly at low peripheral speeds. It is also suitable for continuous rotation where load is variable or intermittent. Mu is equal to 0.0011 cylindrical roller bearing, mu is equal to 0.0045 needle bearing.